Okay, I'm back. Then, which two terms, when I multiply them together, they will be negative 28, and when I add them, they will be negative 3. So they are negative 7 and 4. So, and the middle term is negative 3, so negative 7 and 4, they will be negative 3. So when I solve x minus 7 equal to 0, so x is equal to 7, x plus 4 equal to 0, so x is negative 4. Girls, when I check my answer and substitute x by 7 and x by negative 4, here I will find that the denominator is equal to 0. The solution x is 7 is extraneous because it makes the denominator of the original equation is equal to 0. The only solution is x is negative 4. So I have to check both answers. I have to check both answers because when I substitute 7, the denominator is 0. But when I substitute negative 4, I didn't get 0. So the only solution is negative 4. And here you got the check. Okay, girls? So, again, I want to tell you, the first step that you will multiply the three terms by the denominators that you have, x minus 7 and 2. After elimination and simplifying and distributing and factoring and collecting all the terms together and finding the values of 7, okay, you have now two values for x, 7 and negative 4. Shall I stop here my answer? No. My answer now is incomplete. Why? Because 7 and negative 4, maybe one of them will be extraneous. How I will decide it is extraneous or no? By substituting them in the original equation and checking my answer. When I substitute 7, the denominator is 0. And I never find in math that the denominator is 0. So 7 is extraneous because I got an undefined answer. Let me check if x is equal to negative 4. When I substitute x here by negative 4, I got an answer. So the only solution here that I will use is x is equal to negative 4. Okay, girls? Let's watch here another one.
Hey, let's try another one together. So I want to solve for x, but now I have rational expressions in my equation. Let's check it out. So here's a real complicated looking equation I want to solve. I look at this, I see the denominators with x's in it, not happy, but I'm just going to multiply through by some quantity in order to make the denominators cancel. Well, actually, I see we have the exact same denominator on both sides. So if I multiply both sides through by the quantity x plus 4, I'm going to see, in fact, that I can simplify both sides and actually have a denominator of just 1. So let's check it out together. So I start off by taking the 7x over x plus 4, which equals 6x plus 5 over x plus 4. And now what I'm going to do is I'm going to multiply both sides by the x plus 4. And now we see there's simplification here and simplification here. Technically, by the way, I should really put parentheses here. So what I'm left with is 7x equals 6x plus 5. This we can solve in our heads. Let's just do it in our heads first. Let's subtract 6x from both sides. So 7x minus 6x is just x, so I see x equals 5. It's sort of fun to do it in your head and then write it down to make sure that we got it right. X equals 5. Need to check our answer to make sure this is really okay. So let's take a little quick check. 5 in here. So 7 times 5, that's 35 divided by 5 plus 4 is 9. And the question is, does that equal this side? Put a 5 in for x, that's going to be 6 times 5, which is 30, plus 5 is 35, divided by 5 plus 4, which is still 9. Yep, it sure checks. So we've got one answer, and the answer is x equals 5. Cool. Let's try one more together, because they are kind of fun, and it's sort of neat to see all these things in action. Now, here you'll notice that when I see the denominators in the equation, there are different types. There's x minus 1, but there's also a 3. If you want to sort of clear all the denominators, you can multiply by the least common denominator, which in this case will be 3 times the quantity x minus 1. So I'm going to multiply this by 3 times the quantity x minus 1, and this by the quantity 3 times x minus 1. Now what's going to happen? Well, when we actually write that out, what we see here is so I've got the left-hand side, and then I have the right-hand side. Okay, now, notice that here we got to be really careful. This entire quantity has to multiply the first term and the second term. Now let's think about this. When we multiply the first term, notice that the x minus 1 in the numerator and denominator can be simplified. So I'm just left with 3 times all of that. So that 3 has got to be distributed through to all of that, and so I'm going to see a 6x minus 3. So these cancel, and then I distribute the 3, and I see 6x minus 3. Okay, now I've got to take this quantity and distribute it to here. Notice now the 3's actually simplify, but I'm still left with the x minus 1, which has to be multiplied by the x. So now I have to distribute the x across here, and I'll see x squared minus x. Okay, and then what happens here? Well, here I see a cancellation, a little simplification, and I'm just left with 3. And so when I clean this up, let's see what I see. I see the x squared. I like to write that first. Then I see 6x minus x, that's plus 5x. And then I have a minus 3 equals 3. But really, I see quadratic. I want the quadratic to equal 0. This is so important. Great opportunity to make a mistake. You have a quadratic and it equals 3, and you try to factor that. You can only factor if you have the thing equal to 0, because then if you can factor it up, you know that either one factor is 0 or the other factor is 0. So we got to get 0. So let's subtract 3 from both sides right here. If I subtract 3 from both sides to make that a 0, then I have a negative 3 minus 3 is negative 6. And now that equals 0. Okay, now can that be factored? Well, that's a great question. I'm glad you asked that. Let's see, x, they're going to have differing signs since that's negative. The product has to be 6, and I have to combine them to give 5. So I am thinking 6 and 1. Product, and then perfect. So what are the solutions? Either this equals 0, which means x equals negative 6, or this equals 0, x equals 1. So we have 2 candidates, and now we want to see if they're correct. How do we see? Well, we have to do a check. So let's do a little check. All right, let's try the negative 6. I put a negative 6 in for x everywhere. So I see 2 times negative 6. That's going to be negative 12 minus 1 is negative 13. Negative 13 divided by, and here I have negative 6 minus 1 is negative 7. Okay, plus negative 6 over 3. Okay, looks sort of complicated, doesn't it? So let's see. Does that equal this side? So this side is 1 over negative 7. So the question is, are these equal? All right, well, let's see. Well, let's see. A negative 6 divided by 3 is just negative 2. So this is just a fancy way of saying negative 2, which I could really write as 14 over 7. And this is actually 13 over 7 because a negative divided by a negative is a positive. So here I have 13/7 and I subtract 14/7. That leaves me with negative 1/7, which notice does in fact equal negative 1/7 on the right. So this checks. Great. So this is a solution. Whee! Happy, happy, happy. Okay, and now let's just check the x equals 1. So x equals 1. On the numerator here, I put in a 1. I see 2 minus 1 is 1. That looks good. Divided by 1 minus 1 is 0. Whoa, whoa, 0? I can't divide by 0. That's illegal. This is completely nonsensical. So by plugging in a 1 in here, I see that it makes the denominator 0. That's not good. We're done. We know that this can't be a solution. This actually is an example of an extraneous root, in fact. Where did that come from? It came from the fact that when we try to get rid of the denominator by multiplying through, we accidentally introduced a solution that actually is not a solution to the original equation. Lesson: when you're checking your answers, don't check back to this kind of thing. You've got to check all the way back to the original question, the original equation. Otherwise, you might have actually found something is a root when it really isn't. This is not a solution. This is a solution, and this is not. So forget about this, focus on this, and we're all set to go.
Girls, this lesson is done, okay? But I will continue because, as I told you yesterday, I faced a problem in my program. So I will continue now because we have to follow the weekly plan. Today we should finish this page, this lesson, and tomorrow we should start a new lesson. So the lesson is finished now, but I'm going to continue the rest of the lesson. So you have two choices. If you are free, you can continue with me now, or if you have another lesson now, I don't know you have another lesson or no. If you have another lesson now, you can end the meeting and check the video when I uploaded it after 1 hour from now. So you have the choice, okay? Now we're going to continue solving rational inequality algebraically. You can also solve rational inequalities algebraically. You start by multiplying each term by the least common denominator, LCD, of all expressions in the inequality. However, you must consider two cases. The LCD is positive or the LCD is negative. Example 6. Solving rational inequalities algebraically. Let's watch this one.
All right, let's try to solve an inequality involving a rational expression for ourselves. Now, this is going to actually require a bit of thinking, so I want you to really focus. You are getting mathy. Okay, here we go. It's 10 divided by x minus 3 less than or equal to 2. If this were an equation, this wouldn't be nearly as big of a deal as it's going to be because it's an inequality. And let me tell you why. Remember the big difference between inequalities and equations. In inequality, if you multiply both sides by a negative number, then what happens? Then we have to reverse the inequality symbol. And the truth is, we don't know. See, I want to multiply both sides by x minus 3, you see? But I don't know if x minus 3 is positive or negative. So there's two cases. We have to consider two cases. We have to first assume that x minus 3 is positive, in which case when I multiply through, the sign will not actually change at all. The inequality symbol will not change. But then when we multiply through and assume that x minus 3 were to be negative, then in fact we have to reverse the inequality symbol. You see? So there's two cases here, and it makes sense because we don't know if it's positive or negative, and that really affects things when we're looking at inequality. So, two cases. Let's do case 1. Case 1. Boom, boom. We're going to assume that x minus 3 is greater than 0. In that case, if I multiply both sides by x minus 3, the inequality symbol will not reverse. So then what do I see? If I multiply both sides by x minus 3, it will simplify here, and I'll just be left with a 10 less than or equal to 2 times x minus 3 here. Multiply both sides by x minus 3. Well, now I can solve this. What do I see?
He multiplied both sides by x minus 3. So x minus 3 in the left side, eliminate x minus 3 in the denominator. And in the right side, it is 2 multiplied by x minus 3.
I see 10 is less than or equal to 2x minus 6. I distributed the 2. I'll add 6 to both sides. That makes this a 14. Divide both sides by the positive number 2, so the inequality symbol doesn't reverse. And I'm just left with 7 is less than or equal to x. So it seems like the answer is that 7 is less than or equal to x. That's wrong. That's wrong because don't forget about our assumption. You see, this actually tells me something about x. This implies that x has to be greater than 3. So I have to make sure that x is greater than 3 in my answer. Well, look, this thing is saying x is actually going to be greater than or equal to 7. If 7 is less than or equal to x. So certainly, if 7 is less than or equal to x, then it's the case that x is bigger than 3. So that's actually consistent. And now let's think about this really carefully here, because everyone wants a piece of this. So let's make sure that we're all good here. So we started with this equation right here. And when I distributed 2, I got the 10 less than or equal to 2x minus 6. And then I added 6 to both sides. Now, look what I did. I added 6 to both sides, and look what you let me write. 14? Are you nuts? If you add 6 to both sides, it's 16. Now, why did you stop me? Oh, you did? Okay, I didn't hear you. I'm sorry. And so this becomes an 8. 16.
He did a small mistake here that when he added 6 to both sides to cancel here negative 6. He did here 14. When he added here 6, he did here 14, not 16. That's why he's calling nuts, because he didn't get it.
Divided by 2 now is an 8. All right? Next time you speak up, you just yell. I don't care if your family members are in the other room. You just yell as loud as you can. I'll hear you. All right. Anyway, it's still the case that if 8 is less than or equal to x, then x is certainly bigger than 3. So in fact, this is fine. That is one solution. Now, that's just case 1. Now we've got to consider case 2. So case 2. Case 2. Here we're going to assume that, in fact, x minus 3 is now less than 0. So it's negative, which, by the way, that implies automatically that we need to make sure that x is less than 3. Just to remember that in our back of our heads. Now, what happens here? Well, now when I multiply both sides by the quantity x minus 3, since I'm assuming that's negative, that's actually going to reverse the inequality symbol. So now when I multiply both sides by that, I'm going to see 10 is greater than or equal to 2 times x minus 3. You see how the inequality symbol has been reversed? And so now what do I have? I've got 10 is greater than or equal to 2x minus 6.
He reversed here the inequality sign. Why did he do this? Why did he reverse it? Because he is assuming that x is negative. When we assume that x is negative, we reverse the sign of the inequality. So as he said in the beginning of the explanation, that we will do 2 cases. The first case, that x is positive, and when x is positive, the inequality sign will be the same. And when x is negative, we're going to reverse the inequality sign.
I'm going to add 6 to both sides, so I get 16 greater than or equal to 2x. Divide both sides by the positive number 2. And so I see 8 is greater than or equal to x. So I see that 8 is greater than or equal to x. That means that x is less than or equal to 8. But I know that x has to be less than 3. So this is saying, okay, if you want this to work, x has got to be less than or equal to 8. But to get this whole case off the ground, x has to be less than 3. So when you put these things together, what's the answer? The answer is, well, to get both of these to happen, x has to be less than 3. Because if x, for example, were like 7, which satisfies this, 7 wouldn't satisfy this. So in fact, here I see that to put these two things together, the only way we could put this together with this is to say x is less than 3. So the total solution, so the solution for all, is going to be, I'll write it in set notation, it's the set of all x such that x is less than 3, and then we're going to union that, because it's that or this, x greater than or equal to 8. Kind of complicated, you see it? So it's this or that. Tricky business, but the point is, it just follows from the fact that when you multiply both sides of an inequality by an unknown quantity, we don't know if it's positive or negative. If it's positive, the inequality symbol will not reverse, so you've got to consider that case. But if it were to be negative, then the inequality symbol would reverse, and you've got to consider that case separately. And in both cases, that assumption that we make leads to things that we need to consider for possibly the solution. And it all irons out, and you get it. Whew. Well, congratulations on thinking about rational equations and rational inequalities. I know you can do it. Just take some time and think through it. I'll see you soon.
Okay, girls, it is a little bit more complicated, but it is a kind of the same steps that we did before. But it is more complicated because we're going to repeat the same steps again because of the second case, because we are assuming that we have positive and negative. That's why it is a little bit long, or it is a little bit complicated, because we are assuming that it is positive, and in the second case it is negative. But we are all the same way, that we are trying to get the value of x and substituting and knowing the value and so on. Okay, girls, thank you so much for attending today, and I hope you will do your homework. If you have or facing any problem in your homework, feel free to tell me tomorrow in the beginning of the lesson. And that's it. Do you have any